These are the answers to the light equations. How to work them out. You're given 522 nanometers. You can do dimensional analysis. You know that 1 meter is 1 times 10 to the 9th nanometers. So there's 10 to the 9th nanometers in 1 meter. You get a final answer of 5.22 times 10 to the negative 7th meters. This one is exactly the same except different. This time we're given 4.44 times 10 to the negative 7th meters. And we're going to use the same fact that there's 10 to the 9th nanometers in 1 meter. And we're going to get 444 nanometers. For this problem, we're given a frequency and we're asked to find wavelength. The equation that connects wavelength and frequency is this one right here. So I'm given that the speed of light is 3 times 10 to the 8th meters per second. The wavelength I don't know, and the frequency I do know. 5.7 times 10 to the 14th hertz. To solve for wavelength, I'm going to move the green number over to the other side of the equation. And when I do that math, I get an answer of 5.26 times 10 to the negative 7th meters, or 526 nanometers. The problem also asks, what color is it? To find that, I'm going to take either my frequency and look it up on this chart, or I'm going to take my wavelength and look it up on this chart. It doesn't matter which one you use, but for the wavelength, 526 is going to land somewhere in this range right here, which means my final color of light is green. Number 4 is different because this time we're given a wavelength and we need to find the frequency. We still use this equation. The speed of light, c, is equal to the wavelength times the frequency. The wavelength is 6.2 times 10 to the negative 7th meters, and we are trying to find v, the frequency. When you do the math, the frequency is 4.84 times 10 to the 14th hertz, or per second. Again, it asks what color is it, so we can either take the wavelength in nanometers, which we don't have, we only have the wavelength in meters, or we can take our frequency, 4.84 times 10 to the 14th, and that's going to be somewhere in here, which means this particular type of light is orange. What is the energy of a photon with frequency? We're no longer concerned with wavelength, we're looking for energy, which is going to be this equation right here. The energy of light is going to be equal to Planck's constant, 6.626 times 10 to the negative 34th joule seconds. And we would multiply that by the frequency, which is given to us as 7.3 times 10 to the 14th hertz. That gives us an energy of 4.8 times 10 to the negative 19th joules. That's for one photon, one particle of light. Not very much energy, but it's not very much light. It does say what color is it, so we have to come over one more time and look at our chart. The frequency 7.3 times 10 to the 14th would be somewhere in here, giving us violet. This one is slightly harder in that it gives us a wavelength, but it asks us for energy. That means that we're going to have to use this equation first of all to find the frequency, and then we can plug the frequency into this equation. The speed of light, c, is 3 times 10 to the 8th meters per second, is equal to the wavelength times the frequency. The wavelength is given to us in nanometers, and we have to convert that to meters. just as we did in number 1. When you convert that, you get 6 times 10 to the negative 7th meters times the thing we're looking for, which is frequency. The frequency, therefore, is 5 times 10 to the 14th hertz. We can then take that and solve for energy. The energy is equal to Planck's constant, 6.26 times 10 to the negative 34th joule seconds, times the frequency. And the frequency we just found is 5 times 10 to the 14th hertz, giving us an energy of 3 times 10 to the negative 19th joules. Again, not very much energy, but again, 1 photon of light. It does want to know what color it is, so you can either look it up for the wavelength of 600 nanometers or the frequency of 5 times 10 to the 14th hertz. I'm going to use the nanometers this time, and 600 nanometers is going to fall within this range right here, giving us, once again, orange. What is the frequency of a photon with wavelength 565 nanometers? We're back to only this equation. C, the speed of light, 3.00 times 10 to the 8th meters per second, is going to be equal to the wavelength times the frequency. However, we have to change the wavelength from nanometers into meters. And then all we have to do is find V, the frequency, which gives us a frequency of 5.31 times 10 to the 14th. The color comes from the wavelength or the frequency, and the wavelength 565 nanometers comes from right here, giving us an answer of green. This problem asks us to find the frequency given an energy. We have to look for the equation that ties together energy and frequency, and it is this equation right here. This time we're given the energy, so 6.22 times 10 to the negative 19th joules is equal to Planck's constant, h, times the frequency, v. If I divide both sides by h, I'll get 6.22 times 10 to the negative 19th joules over Planck's constant, 6.626 times 10 to the negative 34th, and that'll give us our frequency of 9.39 times 10 to the 14th hertz. To find the color, look on the frequency chart. 9.39 times 10 to the 14th hertz is going to be up there, greater than 7.5, and that gives us ultraviolet. Sorry, I can't draw in ultraviolet. You wouldn't be able to see it. One last problem. This time we're given the energy here, but notice there is no wavelength as part of the energy equation. That means we're also going to have to use this equation up here. So first we have to find the frequency, and then we can plug the frequency into the other equation. First we set up the problem to find V, the frequency. The frequency is 8.3 times 10 to the 14th hertz. Then we can use the speed of light equation. 3.00 times 10 to the 8th meters per second is equal to the wavelength times the frequency from above. When you solve for the wavelength, you get 3.6 times 10 to the negative 7th meters. For the last time, we have to find the color. You could use the frequency, you could use the wavelength. 8.3 times 10 to the 14th is going to be ultraviolet. To finish our time together, I'll write the color in a lovely slate blue.